All right, today we're looking at two-column proofs. Now for this, you're going to want to refer to your cheat sheet pretty frequently. Know your rules. I've gone ahead and given a more refined version, focusing just on the main rules that we're going to be looking at. So today we're going to be working on exercise problem 39. Now just as a recap, remember what you are doing whenever you are working with proofs. You're going to have 2, 3, or more premises and a final conclusion. Recall that between each premise, you are going to be joining them with a conjunction. And all premises should logically imply the conclusion. Also remember that we only use two-column proofs when we know the argument is already valid. So this will always come out to be valid. If for whatever reason you get a result that is invalid, then go back and check your work. Somewhere there was a problem. So I'm looking at question 39. I broke it down by the 4 sentences you see, and each sentence is going to serve as either a premise or a conclusion. Sentence 1, a fever can be caused by a virus, excuse me, or by a bacterial infection. Well, we know this is going to be premise 1, and we're going to want to assign letters for these statements. The first statement says a fever can be caused by a virus. So I'm going to call that V. Or, well, we ran into a little issue there with the or being a disjunction. So we want to be sure to differentiate that whenever we have a disjunction and a variable, letter V may not have been the best choice. So you could also use P and Q. For today, I'm just going to go ahead and use a different color for the disjunction. So it may have been caused by a virus, or it may have been caused by a bacterial infection, which I will call B. So there's premise 1 written correctly. Now we look at premise 2. The second sentence indicates a new premise. If it is caused by a bacterial infection, so that tells us it's going to be a conditional statement. If it is caused by a bacterial infection, well, we said earlier, caused by a bacterial infection was indicated by letter B, then it needs to be treated with an antibiotic. I'll call that letter A. Third sentence, premise 3, the fever does not need to be treated with antibiotics. Well, earlier we said it needs to be treated with antibiotics was A. So if it does not need to be treated with antibiotics, the negation of that previous statement, which we used A, we will use negation A this time. It is very important that you assign the right values, regardless of what letters you choose to use, to your premises. Again, you may have P, Q, and R in place of these letters, which is perfectly fine. But if for whatever reason you do not use these premises correctly or write them correctly, then doing the two-column proofs will be impossible to show as valid. Now, whenever you see the keyword therefore, now we know we have hit the conclusion. Therefore, the fever is caused by a virus, which earlier we referred to as letter V. So in the end, our goal is to use these 3 premises and combine them with conjunctions and end with this single conclusion. Of course, you could use a truth table for this, but as you know, the more variables you have, the more complex the truth table gets, so that's why we're using these two-column proofs. All right, the first steps are always the same. It's just listing your premises. And in this case, we have 3 premises. So the reason for the first to be listed will always be pretty simple. Again, I'm going to use a different color. So here we have in our two-column proof simply our 3 premises copied. We don't copy the conclusion. That's what we're hoping to get when we're done with all of this. All right, so here's where you want to refer to your cheat sheet. if you look at the major rules that we've been using, notice ponens, if P then Q and P implies Q, you see that the letters in the conditional stay in place in the second half of the equation. PQ, PQ. And again, it's two premises, one a conditional and one a single letter combined with a conjunction. And from this, we could get one final conclusion. Modus tollens, you will see that they're total opposites. If P then Q and not Q implies not P. So we started with PQ, the second half ends with not Q, not P, in a way similar to what a contrapositive may look like. But again, it's a premise of a conditional and a single letter, two premises combined with a conjunction. And from that, we could imply a single value. Hypothetical syllogism uses two conditional statements, two premises combined with a conjunction, and it ends with a conditional statement. If P then Q, and if Q then R, logically implies if P then R. Now, anytime your premises are in the form of a disjunction, you're going to want to change it to a conditional, because as you can see, for us to apply most of these rules, they all require conditional statements. None really use a disjunction. So whenever you see a disjunction in your premise, know that you're going to have to use this rule, disjunction conditional, what I call CD1 or DC1, in which only the first variable changes, and you're going to want to change it to a conditional. So P or Q is logically equivalent to not P, or if not P, then Q. And then of course, you know the rule of negating the conditional, or what I call NCC2, in which the second variable changes. That tells us when a conditional statement is negated, it becomes a conditional statement. Conjunction. So negating the conditional becomes a conjunction, and only the second variable is affected. Well, here we can see a couple of options, and really, as I've mentioned, there's no one right way to approach this. We know that a disjunction is going to have to be changed to a conditional, so we could start with that, or we could approach that later. We also know conditional statement here can be combined with a single letter, and a rule may be found. Overall, our goal is to add conjunctions, and as we saw before, we're going to need at least two, or exactly two, steps that use conjunctions. So I'm going to go ahead and start with the conditional statement, if B then A. And I'm going to combine that with premise 3A. I'm sorry, that is not A, negation A. So what you see here is I've taken statement 2, premise 2, and premise 3, and I've simply combined them using a conjunction. Now what you should see is we have the starts of one of our rules. If B, then A, and not A. Well, when we look at our cheat sheet, what rule does that begin to resemble? Where you have B, A, and then it switches to not A, and that's modus tollens. So what does it logically imply? If B then A and not A would imply the antecedent B in this case. So we simply show the step where we took the conjunction. Well, now in the next step, we can get the logical implication. If B then A and not A implies not B. Now, how did we obtain not B? Through the rule modus tollens, which was done to statement 4 here. Now, one thing to keep in mind is your goal is to use every line here. And if you notice here in step 4, we've used 2 and we've used 3. So it might help to just do a light crossing or a check indicating that these have been used, and we'll no longer need to use those. These two have become this. Well, this in turn became this, so in a way this has already also been used. So you can see here we've done one conjunction, eliminated 2 of the premises, and now we have still one premise and one outcome to use. Well, as I said earlier, you're going to have to change a disjunction at some point into a conditional. And at this point, because we can do a conjunction between these two, it wouldn't help us because it wouldn't be any rule, because no rules that we've seen really use disjunctions. So we want to take premise 1 and we want to change it from a disjunction to a conditional, or what I've called DC1. And we are going to do this to premise number 1. So step 6, we take this. The disjunction becomes a conditional. We know the first variable is affected, so V becomes not V, and B stays the same. So we've used number 1, and we've changed it into what you see here for number 6, using our rule, disjunction to conditional that you see here, where only the first variable changes. Now the question is, what can be used or done with the final 2 values we have? Well, we know we're going to want to combine these in the form of a conjunction. And if you recall, you could see, again, one of the rules present, if not V, then B, combines with not B. So here all I've done is I've taken a conjunction of number 6 and number 5. Use 6 and use 5. So as you're noticing, the 2 conjunctions we knew we would need have occurred. Now we want to see what the outcome of this might be. Well, we see not V, then B, then not B. Again, you may recognize this as modus tollens because things are going to be total opposites and switch places. Not only are they switched, but they're also negated. So not V, then B, then not B would leave us with V. So again, if not V, then B, and negation B gives us V. Not VB becomes not BV. And that is using modus tollens on rule number 7, step number 7. All right, so we've used all our premises and we're left now with one single item, which is, of course, the letter V, which we obtained by using modus tollens on step 7. Well, now that we're left with one thing, this suggests we're done, and to verify that we've done it completely, we just want to compare it to the original conclusion that we should have obtained. We knew we wanted V, we ended with V, so here I can clearly see that I'm completely done, and this problem was logically validated successfully. Remember that in the test, we're going to give you these steps. Although it is important that you know how to set this up, what's even more important is that you know the reasons. So if I were to give you a blank side and you were to see what's happening, would you be able to identify what was occurring? Of course, the first few will always be your premises. You want to look for steps of conjunctions, and you want to identify what rules were used to obtain new values. So overall, this is question 39. Stay tuned for the next problem.